Hi, everyone. My name's Jonathan. I work at Snapcommerce. I'm the data platform lead there. And today I'm going to give an overview about, how to get started with DBT, which is my personal favorite data tool out there in the market. And I'll give a description of what it is and, how you can use it on your data team. For any folks who are not aware, like familiar with the tool, or they're just trying to break into data, I will try to make it as generalized as possible and won't dive in too technical. And so hopefully, if you have any clarification questions, you could just ask me after at the end or even during. I'm not sure if that's possible, but yeah, let's get started. So first of all, just a little bit about the company. So Snapcommerce, the mission statement is to provide access for everyone to experience more of what life has to offer, regardless of income or circumstance. What this actually means is that we are building a new way to shop on mobile, which maximizes savings, benefits, and rewards. We've already started with hotels and have driven nearly $1 billion in sales since the company's inception, and we're quick expanding into new areas tied together under the same platform. And about myself, I've been with the company about 3 years, and before that, I got my start doing economic research at the Bank of Canada. And then after that, I've done stints at Shopify and Instacart, where I sort of first got exposed to data and the tech industry. And over time, I've grew from an analyst, or not even from an analyst, but from someone who did quantitative research to an analyst, to a data engineer, and finally an analytics engineer, which is a bit of a hybrid of the two that I'll go into later on. In terms of Snapcommerce's data infrastructure, there's really three main evolutions that I would talk about. So that I think probably many other companies over the last 5 years have experienced as well. The first one is where you migrate from probably running a lot of analytics off of your production databases, your application databases like Postgres, to a data warehouse like Snowflake. And I'm sure many companies sort of experience, especially startups, sort of when they first can prove out the data warehouse, that's when they are really starting to get serious about data. The second major evolution was from ETL to ELT, which really was unlocked with the explosion in the data industry, with the rise of data warehouses like Snowflake and Redshift, and then on the accompanying pieces like Stitch and Fivetran. So moving from an ETL paradigm where the data engineers owned a lot of the data modeling and transformations to one where all of those transformations are happening in the warehouse was a really pivotal shift for the company. As such, that leads to the third major evolution, which is building a transform layer using DBT. So once all of that data in an ELT context gets loaded straight into the warehouse, someone is there, someone has to do something with it. And what ends up happening is you need some sort of organization, some sort of tooling to assist you as you're building out all of this data, this just giant schema and all of these different data models. So what is DBT? As I sort of alluded to in the previous slide, it's the transform step in an ELT framework where extract, load, and then transform. So as you can see in the bottom here, you start with loading your data into the warehouse in its raw form. You then obviously there's a step before here where you extract it from the source, like an API or something. And then after you load it into your warehouse, you transform it using DBT and then a version controlled repo. So it's effectively a CLI tool that allows you to build tables, views, and other objects into your warehouse, which can then be consumed by your BI layer at the right side here. And it's a CLI, it's an open source tool, so you can deploy it any way. You can use DBT Cloud, which is the cloud service offered by the makers of DBT, as well as you can even use Fivetran, you can use Airflow, many different ways to deploy DBT. To get even more detailed and more specific, at its core, DBT takes regular select statements. So if you're familiar with SQL, this is just a simple select star where you're just pulling out a section of data or a subsection of data, and it translates those select statements into create statements. Where you're creating tables or creating views that represent the SQL query, the select query. That's really all it is. And then it gets more fancy when you're talking about incremental, inserts, and merges. But at its core, DBT accomplishes the translation of a select statement into a create statement. And why should you adopt the tool? Well, it's very beneficial for several reasons. It's, first of all, it provides you with a single source of truth for all of your business logic. There's no need to spread that out into several different places. It represents your business logic in pretty much the most accessible form possible in SQL, which is the lingua franca of the modern data team. As such, you can version control your analytics code. You can roll back. You get reviews on this. And in previous systems, it wasn't so easy to have version control as it is when your transformation layer exists as a code repo. As you can see below, you can track the lineage, data lineage, very easily. So from source all the way to these destinations, these final data models where that might be queried by an end user, you can really see the progress of every single data point as it goes along your tree. And one of the core performance benefits is that because it facilitates the creation of these tables, you can always pre-compute data sets for faster queries and dashboards. If you're just querying source data in your BI tool or even just standalone, that's going to be very slow as your startup or your company scales over time. Eventually, you need to not only model that data, but build pre-computed roll-up tables so that you can quickly access a lot of your data. So I guess the main thrust of this conversation is to talk about what I've learned having worked with DBT or even any transformation layer solution over the past 2 years. And the first thing I want to start out with is figuring out who exactly is responsible for owning and building out your transformation layer. It's important to define the owner and as well delineate clear roles and responsibilities for members of the data team. Otherwise, there'll be it can get a little chaotic when it's unclear who owns specific data models or who is not necessarily allowed to touch certain things, but whose responsibility it is to build out and maintain certain stars or certain parts of your schema. So an example might be that you have analytics engineers, as the hybrid data engineer analyst folks who own the core models, and they're responsible for building out every, your core facts and dimensions, while your analysts, whose job really at its core is to analyze data, might wade their toes into data marts and create like custom views that join these different dimensions and facts together when they need to, and then also perform their core responsibility of analyzing that data. And then data engineers are there to help with deployment. Sometimes you might have a complicated deployment of DBT, and data engineers might be there to help you maintain the repo and have a continuous deployment mechanism. So my recommendation is at least to, if you are going to build out your transform layer, you probably want to at least either start an analytics engineering team or at least train analysts and data engineers in data modeling, because things can spiral and get chaotic very quickly as you start building things without a clear design or a clear idea of where you're going. So having somebody who has expertise in this area, or even training people to develop that expertise, will help a lot as you sort of go along your journey in this transform layer. I'll summarize the keys to a healthy project with the following 4 points. First, you want a clear and intuitive data model. This means that you pick something and you commit to it, rather than sort of creating a melange of different data models or having none at all. Secondly, you want a consistent project structure and taxonomy, which extends not only to the way that your repo is organized, but also the way you name things. You want strong testing and documentation, which is really critical for allowing people to easily navigate the repo, in this case of documentation, as well as to ensure that you have at least the bare bones of data quality checks, which every data team needs to factor in at the end of the day. Finally, you want to enforce all of the above in CI/CD, and I'm going to explain in the next few slides exactly how to do that. So the first part about a data warehouse design methodology. I'm not an expert in data warehouse design or data modeling. However, I think at its core, you should pick a system that tells you when and how to add data models. I personally, have a lot of experience with dimensional modeling, the Kimball style approach. I've used it in pretty much every company that I've worked at. And I think it's important to start training data team members and data consumers to think in terms of dimensional models if you are going to pursue that route. So having them think about facts and dimensions as a way to organize data in their heads is very useful. So I think I would probably recommend a really simple Kimball-inspired star schema, which most folks might already have built into their applications that they bring in to the warehouse. It doesn't, you don't have to be as super religious about Kimball, but at least following the core sort of lessons there, and is probably a great place to start, unless before you get serious about Snowflake or data fault or any of the more complex methodologies. The companion piece to your data model or schema, as people call it, is the project structure for DBT. I view this in terms of there are how that your data models, the way that they are constructed and the way that they relate to each other in a data sense is your data warehouse methodology. But the way that models relate to each other in terms of your DAG, where the DAG, if you're not familiar, is this sort of tree of models and relating to each other that flows in a single direction. Ensuring that you don't have in sprawl and chaos and giant webs of connections and relationships is really important. And I can tell you that from experience. You're going to want to minimize the complexity of your DAG and make it really, really easy for people to know which model to use. This also helps avoid performance bottlenecks because you don't have single models holding up a huge part of your DAG as you're trying to rebuild your warehouse every hour or every day. So really, the main focal point here is standardizing how models should relate to each other. One way to look at this is different layers in your DAG, and the DBT Labs or former DBT Labs community manager Claire Carroll wrote a seminal post on this topic, which you should probably use as a starting point, which scopes out the different layers that you'll have in your DAG. So a source layer, a base layer, a staging layer, and then your facts and dimensions here. So you can see a lot of these layers in this diagram here, but there is a lot more detail in this post, and I recommend you go use that. So for us, we use a fairly simple model. This is again, we do sort of, I guess, Kimball light, but the way that we've organized our DAG is essentially the same as I showed before. So a source layer, a base layer, staging layer, and then your dimensions and facts, and then data marts on top of that, which essentially join together dimensions and facts and are more domain specific. And I think this is a fairly simple model that anybody could implement. Again, naming things consistently sounds trivial, but it can actually be really important. It should be really obvious from a model name and even a column name what exactly that model or that column describes. A model name like fact orders or dim user is very obvious, and and if you start thinking in terms of dimensional modeling, then you really understand how these facts and dimensions start to join together. And it doesn't have to be hard work to figure out which model, which table to query. Similarly for column names, you want to avoid simplistic names like ID or date, and usually put things make those names very descriptive. I've even seen some companies or some projects have pretty explicit ID names, like even putting the entire, like dim user ID to, as the user ID, just so whenever you join it to a different fact table for example, in a MART model, you're going to you're going to know exactly what that ID or that dimension column is referring to and which dimension it comes from. So I recommend using prefixes on models to clearly denote what the model is, like what type of data model it is. And I would also consider using column prefixes in dimensions, although that might be a bit more of an advanced strategy. And then I guess my final point here is in terms of like the core recommendations is, you want to have a great testing and documentation culture. Testing models for uniqueness and null values is a really sort of the core set of tests that I would recommend for every single model. You can use surrogate keys, a la Kimball as required. And the documentation itself, should live right next to code. So sometimes inline comments, as well as, making use of DBT's built-in documentation features to really make sure that, an individual contribution to the repo involves not only a new data model or an augmentation of a data model, but the related documentation and testing as well. The other thing is snapshots. I think snapshots which is another feature built into DBT, will always prove their usefulness. They will save you one day when you need to refer back to exactly when a model, the data in a model drifted. So I would definitely snapshot your key models there. So my recommendation is test and documentation coverage is required on every model. But at the same time, you can go overboard. So, it's important to not over test. Otherwise, you're going to be dealing with a large backlog of failing tests that never get cleaned up. And that's not fun. So all of the things that I just described before, the way that you keep your project clean and simple and intuitive and comprehensive, all of that can be enforced in CI, in continuous integration itself. So you can mandate test coverage. We require a unique and a not null test for every model. You can require documentation. Every column or every model has to have a description and related documentation. Taxonomy, naming, the way you name things, the way you name IDs, the way you name models can be enforced as well. Relationships, this one is a bit trickier, but the way that a model might, it might pull from a source directly, or you might have a staging model pulling from a MART model, and these types of relationships you can sort of guard against in your project in CI to ensure that your DAG flows very cleanly. And there's more advanced tooling here in the space that would allow you to do even more, but beyond simply looking at the relationships between data models. Linting is something we also do, where it's the same that you would have on a regular code repo. You want to ensure that your code follows all of your predefined rules. And then there's a tool called Datafold, which we're launching now, which promises to be a way of tracking the data impact of a certain pull request. So by doing a diff between a production version and the new version that you're creating. And then overall, our CI and CD process uses a tool called Slim CI, which I won't get into, but you can read about it online, as well as a garbage collection, which is a unique, or I guess a custom macro that I built, which cleans up old or deprecated data models. And I think you can find that on my GitHub. And I think this is my last slide, so I have no idea if I went horribly over time, but this, just a couple more lessons that I've picked up along the way. Just, having a powerful staging layer where, if you're always viewing the same sets of models at the same time, it makes sense to bring them together into an individual model. And that can really be powerful in an operational sense, as you're sort of saves your analyst or your consumer a lot of time. Another thing I've noticed is a lot of people still maintain different business logic in a few different places. So I think it's very tempting to put business logic in Looker or in your BI tool, when realistically I would argue that you should maintain all of it in DBT, just standalone. Even your joins. I personally would prefer to keep all of that logic in DBT. Deployment is, if you're getting started, should be kept simple. A simply hourly job and a nightly job are very, it will get you pretty far. And then eventually you can get a lot more complicated when it comes to certain triggers and custom and external runs. But yeah, for getting started, I would say keep things very simple. I know when Shopify went live with DBT, they had one daily run. They might even still have one, and that pretty much got them, pretty far. And then last thing is just use packages whenever possible. There's a lot of great packages out there with custom tests, with custom models, and it's starting to get to the point where it's likely that what you are trying to build might already have been built out there. So it's important to check the hub first and see if you can reuse something.
Could you quickly explain snapshots again?
Yeah, I think so. So DBT has a built-in implementation of type 2 slowly changing dimensions, which effectively means that when you run your snapshot, it'll freeze your data. It'll freeze the table or your query. It'll compare it against the snapshot table, and then append new rows which tell you, if a row has changed, what's new, and if there's been any drift. So it's really useful. I mean, it's the classic use case is for dimensions, but I think it's really useful as well, just for any type of data model that you want to track and see if it's drifting. If you have a really complex, product or application with a lot of high volumes of data, even a microservices architecture, things are liable to change. Things drift. Things happen, and it's a useful tool in order to track those changes and track drift, so you can really figure out the root cause.